Welcome. This is Fee 304, Study Session 3. Kuhn and Scientific Revolution. Introduction. In this study session, we will examine Thomas Kuhn's paradigmatic approach to science. Learning outcomes. When you have studied this session, you should be able to 1. Describe normal science. 2. Discuss Thomas Kuhn's idea of paradigm shift or scientific revolution. 3. Discuss scientific revolutions. Normal science. For Kuhn, normal science is a period when scientists are basically preoccupied with solving a problem within a paradigm without questioning the paradigm. In the earlier mentioned example, when scientists discovered that the orbit of Uranus contradicts Newton's law of mechanics, they did not abandon or question Newton's paradigm, but they sought to resolve the problem within it, and it paid off, even though Popper might reject this approach as uncritical, since in his view, scientists must constantly question their assumptions. The fact remains that progress can hardly be achieved if scientists constantly question the assumptions within their operative paradigms. Thus, while great scientists as Newton, Dalton, and Darwin constructed new paradigms, most scientists explicated the details of the paradigms by performing normal science within them, thereby extending the body of scientific knowledge. Kuhn's paradigm shift and scientific revolutions. Kuhn is of the opinion that, contrary to popular beliefs, the progress of science is not always smooth and stable as normal science makes it seem. According to him, science historically progresses by way of scientific revolutions. A scientific revolution occurs when scientists are dissatisfied with a given paradigm and cope up with entirely new ways of resolving problems. Once this new approach succeeds, it becomes a new paradigm for normal science and replaces the old paradigm. Some examples of scientific revolutions are the replacement of the geocentric model with the heliocentric model of the universe, the replacement of Aristotelian physics by Newtonian mechanics in the 17th century, as well as the replacement of Newtonian mechanics by Einstein's theory of relativity in the earlier parts of the 20th century. Thus, science does not progress smoothly or linearly. Rather, its progress consists in paradigm shift or displacement. There is no perfect theory in science, and science at any given time consists of unresolved puzzles. There is usually the belief among scientists that such puzzles can be solved in a paradigm during normal science. If, however, the number of unresolved anomalies cumulates into a critical mass, some are likely to start questioning the paradigm itself. A scientific revolution occurs when a new paradigm gives better explications of these anomalies. Surely, not everyone will shift or be converted into this paradigm, and there are usually violent debates between adherents of the old and new paradigms. Most at times, the new paradigm gradually triumphs, not so much because it is convincing, but because older and more conservative scientists die out and a new generation that is familiar with it grows up. 1. At times, one chooses to dissent from sentences or symbolic generalizations in one scientific community. Justify this in the light of your understanding of Thomas Kuhn's notion of paradigm shift or scientific revolution. 2. Kuhn says that science historically progresses by way of scientific revolutions, since every scientific domain has limited validity, and a scientific revolution occurs when scientists are dissatisfied with a given paradigm, critique it, discovers its inadequacies, and come up with entirely new ways of resolving problems. How rational is science? As Kuhn sees it, the progress of science is not rational in that there is no common ground for deciding the rationality of sticking with an existing paradigm or shifting to a new one, since, as stated earlier, no theory can be conclusively verified or falsified. This inconclusiveness is due to the fact that observations that tend to falsify an old paradigm can be dismissed as resulting from experimental error, or certain auxiliary hypotheses can be created to explain them. This lack of a rational way of preferring one paradigm over another led Kuhn to liken paradigm shift to a religious conversion, with such actions being influenced by some unscientific factors like personal ambition and social pressure. Kuhn's idea is plausible because the history of science shows that scientists are not solely motivated by the love of truth, but also by other factors such as ambition, vanity, and enmity. Scientists engage in priority dispute over who first discovered a particular law or came up with a given theory. Also, they are humans, and like other persons, they are interested in their social status and public recognition, such as being awarded. For instance, the astronomer Edwin Hubble, 1889 to 1953, showed his desperation for getting the Nobel Prize when he employed an expert in public relations to help him. Unfortunately, Hubble's effort came to naught as astronomy has no Nobel Prize. Social factors such as the military desire for power, big business desire for profit, as well as adequately funded areas of research play significant roles in the development of science, as well as in determining scientists' choice of problems to resolve. Some scientists even prefer less controversial areas of research than some politically sensitive ones. In addition, their desire to get promoted puts them under the pressure of conforming to the beliefs and values of the paradigm they find themselves. Criticisms against Kuhn's position. Some objections can be pressed against Kuhn's philosophy of science. These are: 1. Most scientists in normal science do not question the paradigm within which they operate. Instead, they focus on puzzle solving. 2. The history of science indicates that science does not progress linearly, but by a series of revolutionary leaps. 3. There is no basically rational way of choosing between rival paradigms in times of scientific crisis. Criticisms in normal science. Even though there is some truth in Kuhn's claim that normal scientists hardly question the paradigm within which they operate, it is not a good thing for them not to do, because their beliefs will end up being dogmatic. What we have to note is that scientists are not dogmatic, but they question certain assumptions in their areas. Scientific community is one with a critical mind, and the scientists probe deeply into any assumption in their areas It is therefore not true that normal science is not a critical one. Scientific revolutions. Take 2. Scientific revolutions. Kuhn's account of the history of science in relation to revolutions dangerously suggests that our body of current scientific knowledge will be someday eroded by a new revolution. It is not completely true that older paradigms vanished without trace when replaced through paradigmatic revolution. The history of science shows that scientific knowledge is cumulative in nature and that science is edging closer to the truth by each passing day. Rather than conceive new paradigms as displacing older paradigms without trace, new paradigms are more or less inclusive. For instance, notwithstanding its replacement with Einstein's theory of relativity, Newtonian mechanics is still valid in some important respects and is a special case of the relativity theory. In the same vein, although Aristotelian physics was replaced by Newtonian physics, it is reasonable to explain certain everyday phenomena, while Newtonian physics can explain far more phenomena than Aristotle's physics. Einstein's relativity theory explained more phenomena than Newton's physics, especially the motion of electrons within an atom and the nature of a gravitational field near a black hole. It is reasonable to see science as progressing cumulatively. This is because while it is possible for some well-confirmed theories to turn out to be wrong, it is difficult to think that future scientists will come up with counter-theories that the Earth does not orbit the Sun, or that water does not consist of hydrogen and oxygen. Whatever new findings they may arrive at will be inclusive of the old facts. Choosing between rival paradigms. During periods of scientific crisis, Kuhn's position is that the scientist's choice of paradigm is not purely rational, but is influenced by unscientific elements as personal ambitions and social pressure. This is true to some extent, but it is necessary to view it from another angle by distinguishing between the origin of a belief and its justification. The origin of a belief is not of any importance in science. What is important is that the theory is testable, and if it is confirmed by experiment, it is acceptable, but if it is not, it is thrown out. Kuhn's position is a form of relativism since he asserts that different paradigms interpret the world differently, and their truth claim cannot be conclusively proved. Rather than see scientific knowledge as relative, we should consider it as judgmental. This is so because judgment is what scientists need in deciding, for instance, which anomalies to take seriously and which to dismiss as experimental error, which factors should be observed and which can be ignored without problem, among other things. Although these judgments could turn out to be wrong, it is not irrational to make them. That is, even though astronomers were wrong in postulating an undiscovered planet, that is Vulcan, take 2, as a reason of Mercury's irregular orbit, such hypothesis was rational, given the success recorded by similar auxiliary hypotheses based on Newton's mechanics. The point here is that the fallibleness of reason does not mean that it is without value. Science derives great strength from its self-correcting nature. Even though dogmatism might set in within a scientist's operational paradigm, the competitive nature of scientists ensure that their findings are cross-checked and the better ones are accepted. It takes less time for genuine ideas to gain acceptance. For instance, while it took more than 100 years for Copernicus' theory to be generally accepted, physicists accepted Einstein's theory in less than 15 years. In the same vein, scientists usually weed out or reject theories whose results cannot be replicated by other scientists. The point in all this is that even though there is no well-established criterion for choosing between varying paradigms, some theories, as evidence proves them, looks more plausible than others. It therefore follows that one would be justified in dismissing a theory as irrational beyond a certain time if it is an implausible one. ITQ. Is Kuhn's paradigmatic approach to science a form of relativism? Yes or no? ITA. If you have chosen yes as answer, then you are correct. In fact, different paradigms interpret the world differently and judgmentally, such that their truth claim cannot be conclusively proved. Knowing that hypotheses can never be conclusively verified or falsified, how will you describe the concept of truth as it applies to science? Study session summary. In this study session, you learned that science is not static. We explained how paradigm shifts and how revolutions occur in science. We noted also that no scientific theory is absolute. Finally, we listed the elements of relativism in Kuhn's account of science, which necessarily requires criticality and inquiry. We have come to the end of study session 3. Thanks for listening.